NEC 314.23e states threaded metallic raceways, fittings, and boxes shall be permitted to be used for the mechanical protection of the cord. This means that as long as the pipe coming in is threaded, it can be used to protect the cord. In this case, there is rigid conduit coming from the switch at the pump station that is threaded into a polyvinyl chloride Schedule 80 90-degree bend, which is then connected to a Junction junction box. Since the rigid conduit is threaded into the brass hub of the junction box, it provides mechanical protection for the cord. Your friend's concern is likely based on the fact that the National Electrical Code does not specifically address a changeover from rigid conduit to polyvinyl chloride. However, the National Electrical Code does allow for the use of different types of raceways in the same system, provided that the transition is made in an approved manner. In this case, the transition from rigid conduit to polyvinyl chloride is made with a threaded 90-degree bend, which is an approved method. Furthermore, the use of polyvinyl chloride conduit for the portion of the wet niche is appropriate because polyvinyl chloride is resistant to corrosion and can be buried directly in the ground. The number 8 American wire gauge insulated wire within the polyvinyl chloride conduit is likely used for bonding purposes, which is also a National Electrical Code requirement for pools. Based on the information provided, it appears that the installation is compliant with the National Electrical Code. The use of rigid conduit for the mechanical protection of the cord, along with the threaded transition to polyvinyl chloride, is an acceptable method. Additionally, the use of polyvinyl chloride for the wet niche and the bonding wire are both appropriate. Therefore, running rigid conduit all the way from the pump station to the pool lights junction box would be excessive. The current installation provides adequate mechanical protection for the cord and meets the National Electrical Code requirements for pools. The primary concern when evaluating an electrical installation near a pool is safety, and adherence to the National Electrical Code helps ensure that safety. Now let's delve deeper into the specific aspects of this pool light junction box installation and the relevant electrical codes. We need to consider several factors. Firstly, the mechanical protection of the cord supplying power to the pool light is crucial. NEC 314.23e explicitly allows threaded metallic raceways, fittings, and boxes to be used for this purpose. The key is that the connection must be threaded, ensuring a secure and mechanically sound connection. In this scenario, the rigid conduit provides this protection up to the point where it transitions to the polyvinyl chloride conduit. Secondly, the transition from rigid conduit to polyvinyl chloride conduit needs to be evaluated. While the National Electrical Code doesn't explicitly detail every possible transition scenario, it generally permits the use of different types of raceways within the same system. However, this is provided that the transition is made in an approved manner. The use of a threaded 90-degree bend to connect the rigid conduit to a polyvinyl chloride conduit is a common and accepted practice, as it maintains the mechanical integrity of the raceway system. Thirdly, the use of polyvinyl chloride conduit for the section running to the wet niche is appropriate. Polyvinyl chloride is known for its resistance to corrosion, making it suitable for direct burial in the ground and exposure to potentially corrosive pool environments. This is a significant advantage over metallic conduits, which could corrode over time. Fourthly, the presence of a number 8 American wire gauge insulated wire within the polyvinyl chloride conduit is likely for bonding purposes. Bonding is a critical safety measure in pool installations. It ensures that all metallic parts of the pool and its equipment are electrically connected. This minimizes the risk of voltage differences and potential electric shock hazard. The National Electrical Code has specific requirements for bonding pool equipment, and a number 8 American wire gauge wire is often used for this purpose. Fifthly, let's consider the distance and practicality of running rigid conduit all the way from the pump station to the junction box. While using rigid conduit for the entire run might seem like a more robust solution, it's not necessarily required by the National Electrical Code. Furthermore, it can be significantly more expensive and labor-intensive to install. The combination of rigid conduit for mechanical protection and polyvinyl chloride conduit for corrosion resistance offers a balanced and compliant approach. Sixthly, it's important to verify that all components used in the installation are listed and labeled for their intended use. This includes the conduits, fittings, and junction boxes. Listed products have been tested and certified by independent testing laboratories to meet specific safety standards. Seventhly, the junction box itself must be suitable for its environment. Given its proximity to the pool, it should be rated for wet locations. This ensures that it can withstand exposure to moisture and prevent water from entering and causing electrical problems. Eighthly, the height and distance of the junction box from the pool's edge are also important. The National Electrical Code specifies minimum distances to prevent accidental contact with electrical components. In this case, the junction box is 4 feet away from the edge of the pool and at the proper height, which meets these requirements. Ninthly, the presence of the brass hub on the junction box is significant. Brass is a conductive material, and it can serve as a grounding point. However, it's crucial to ensure that the brass hub is properly bonded to the grounding system. This typically involves connecting a grounding conductor to the hub and running it back to the main electrical panel. Tenthly, the overall goal is to provide a safe and reliable electrical installation for the pool light. This involves not only following the specific requirements of the National Electrical Code, but also using good workmanship practices. All connections should be clean and tight, and all wiring should be properly supported and protected. Therefore, reviewing the entire installation would include checking for any signs of damage or deterioration. Look for any cracks or breaks in the conduits, fittings, or junction box. Also, inspect the wiring for any signs of fraying or damage. Replace any damaged components immediately. It is also essential to test the ground fault circuit interrupter protection for the pool circuit. Ground fault circuit interrupters are designed to detect small electrical leaks and quickly shut off power to prevent electric shock. Test the ground fault circuit interrupter regularly to ensure that it is functioning properly. Lastly, consider documenting the installation with photographs and diagrams. This can be helpful for future maintenance and troubleshooting. Keep a record of all the components used and their specifications. In conclusion, the pool light junction box installation, as described, appears to be compliant with the National Electrical Code. The use of rigid conduit for mechanical protection, the threaded transition to polyvinyl chloride conduit, and the presence of a bonding wire all contribute to a safe and reliable installation. However, it's essential to verify that all components are listed and labeled, the junction box is suitable for its environment, and all connections are properly made. Regularly inspect and maintain the installation to ensure its continued safety and reliability. Remember, electrical safety is paramount, especially in and around pools. If there are any doubts about the safety or compliance of an electrical installation, it's always best to consult with a qualified electrician. Furthermore, let's delve into some more advanced considerations regarding pool light installations and the National Electrical Code. There are several nuances and potential areas of confusion that are worth exploring. Firstly, let's discuss the concept of equipotential bonding in more detail. Equipotential bonding is a technique used to minimize voltage differences in and around a swimming pool. It involves connecting all metallic parts of the pool structure, including the reinforcing steel, the pool equipment, and any nearby metallic objects, to a common grounding point. The purpose of equipotential bonding is to create an electrically safe environment where there are no significant voltage gradients that could cause electric shock. The National Electrical Code has specific requirements for equipotential bonding in Article 680. These requirements vary depending on the type of pool and the specific equipment involved. However, the basic principle is to connect all metallic parts to a common bonding grid using a continuous unbroken conductor. This conductor is typically a number 8 American wire gauge copper wire, and it must be installed in a manner that ensures a permanent and reliable connection. Secondly, let's consider the different types of pool lights that are available. There are two main types of pool lights: incandescent and light-emitting diode. Incandescent pool lights have been around for many years, and they are relatively inexpensive. However, they are also less energy efficient and have a shorter lifespan than light-emitting diode lights. Light-emitting diode pool lights are more energy efficient, have a longer lifespan, and can produce a wider range of colors. However, they are also more expensive than incandescent lights. The National Electrical Code has specific requirements for the installation of both types of pool lights. These requirements address issues such as the maximum voltage allowed, the depth of the light below the water surface, and the type of wiring and conduit that must be used. Thirdly, let's discuss the use of ground fault circuit interrupters in pool circuits. Ground fault circuit interrupters are required by the National Electrical Code for all circuits that supply power to pool equipment, including pool lights. Ground fault circuit interrupters are designed to detect small electrical leaks and quickly shut off power to prevent electric shock. They are an essential safety device for any pool installation. Ground fault circuit interrupters should be tested regularly to ensure that they are functioning properly. The National Electrical Code requires that ground fault circuit interrupters be tested at least once a month. To test a ground fault circuit interrupter, simply press the test button on the device. If the ground fault circuit interrupter is working properly, it will trip and shut off power to the circuit. Fourthly, let's consider the importance of proper grounding in pool installations. Grounding is the process of connecting all non-current carrying metallic parts of an electrical system to the earth. This provides a low resistance path for fault current to flow back to the source, which helps to trip the circuit breaker or fuse and shut off power to the circuit. Proper grounding is essential for electrical safety in any installation, but it is especially important in pool installations. The National Electrical Code has specific requirements for grounding pool equipment. These requirements address issues such as the size of the grounding conductor, the type of grounding electrode that must be used, and the location of the grounding electrode. Fifthly, let's discuss the use of flexible cords in pool installations. Flexible cords are often used to connect pool equipment, such as pumps and filters, to the electrical system. However, flexible cords must be used with caution in pool installations, as they can be easily damaged by water and chemicals. The National Electrical Code has specific requirements for the use of flexible cords in pool installations. These requirements address issues such as the type of cord that must be used, the length of the cord, and the way the cord must be supported and protected. Sixthly, it is important to always consult with a qualified electrician before performing any electrical work on a pool. Electrical work can be dangerous, and it is important to have the work done by someone who is knowledgeable and experienced. A qualified electrician can ensure that the electrical installation is safe and compliant with the National Electrical Code. In addition, they can provide valuable advice on the best way to install and maintain pool equipment. Seventhly, regular inspections and maintenance are essential for ensuring the continued safety of a pool electrical system. Pool electrical systems should be inspected at least once a year by a qualified electrician. The inspection should include a thorough examination of all wiring, connections, and equipment. Any damaged or deteriorated component should be replaced immediately. In addition to regular inspections, it is important to perform routine maintenance on pool equipment, such as cleaning the pump and filter and checking the water chemistry. Proper maintenance can help to prevent electrical problems and extend the life of the equipment. Eighthly, consider the specific requirements for underwater luminaires, which are addressed in NEC 680.23. This section provides detailed guidelines on the installation, wiring methods, and grounding requirements for underwater lighting fixtures. It is important to carefully review this section to ensure that the pool lights are installed in a safe and compliant manner. Ninthly, always refer to the latest edition of the National Electrical Code for the most up-to-date requirements. The National Electrical Code is revised every 3 years, and it is important to stay current with the latest changes. The National Electrical Code is available for purchase from the National Fire Protection Association and other organizations. Tenthly, remember that electrical safety is a shared responsibility. Everyone who uses a pool should be aware of the potential electrical hazards and take precautions to avoid them. Never swim during a thunderstorm, and never use electrical appliances near the pool. By following these safety tips, everyone can help to prevent electrical accidents and ensure that pools are safe for everyone to enjoy. Therefore, the overall goal of pool electrical safety is to create an environment where the risk of electric shock is minimized. This requires a combination of proper design, installation, maintenance, and user awareness. By following the requirements of the National Electrical Code and taking precautions to avoid electrical hazards, it is possible to create a safe and enjoyable pool experience.